Look at this. What you see is fire. You see millions of pounds of force blasting through the atmosphere. But that's actually an illusion. Raw power alone can't put a rover on Mars. And it definitely can't guide a missile through a 1-meter window from 1,000 miles away. Brute force just makes a very expensive explosion. The real secret controlling all that fire isn't the engine. It's math. More specifically, a 300-year-old invention called calculus. Now let's talk about the strange paradox at the heart of rocket science. In the 1890s, a Russian scientist named Konstantin Tsiolkovsky discovered something terrifying. If you want a rocket to travel farther, you need more fuel. But fuel is heavy, so to lift that extra fuel, you need even more fuel. And to lift that fuel, you need even more fuel again. It becomes an endless loop. Regular math struggles with this problem because a rocket's weight isn't constant. Every second, the rocket is burning huge amounts of fuel. That means the rocket is literally getting lighter while it flies. So how do you calculate the speed of something whose weight is constantly changing? This is where integration comes in. Integration is a tool from calculus that lets us look at tiny changes over time and add them all together. Using integration, scientists can calculate exactly how the rocket's changing weight affects its speed. This leads to something called the Tsiolkovsky rocket equation, which tells engineers exactly how much fuel they need and when the rocket must drop empty fuel tanks to keep flying efficiently. Without this math, rockets simply wouldn't work. Now comes the hard part. The rocket has launched. Now it's flying at Mach 10. Air resistance, gravity, and tiny changes in direction are all trying to push it off course. A human pilot can't react fast enough to control something moving this fast. The computer has to do it. And to do that, it needs another tool from calculus: derivatives. If integration adds things up over time, derivatives do the opposite. They measure how fast something is changing right now. For example, if the computer knows the missile's position, a derivative tells it the missile's speed. Take another derivative, and it tells you the acceleration. This is how guidance systems work. Modern missiles use a method called proportional navigation. Instead of simply aiming at where the target is, the computer watches how the target's angle is changing. Using derivatives, it predicts where the target will be in the future. Then the missile constantly adjusts its path, hundreds of times per second, so that both objects arrive at the same point in space. Here's the strange reality behind some of humanity's greatest technologies. We love the fire, the noise, the explosions, but those are just the engines. The real control system is math. Calculus is the steering wheel. Without integration to solve the fuel problem, and derivatives to predict motion, every rocket launch would just be a spectacular failure waiting to happen. So next time you watch a rocket launch, don't look at the flames. Look at the math.